Okay. So I got 3 modules to cover here. The second one is the big one. So we're on module 10. Now it depends upon your server purpose and what you're running on your app as far as applications, but in the HPC market we are using 2 types of programming paradigms. One is called OpenMP, the other one is called MPI. For OpenMP we are using Intel compilers. And I do have a couple of programs if anybody wants to play with OpenMP. In the lab, there is a Code 2 MP that is multi-threaded with OpenMP. And GNU compilers do provide OpenMP capabilities now, but they don't do auto-tasking. In other words, with the Intel compiler, I can add a dash parallel, and it will automatically create an OpenMP threaded application for me. The other multi-threading paradigm being used is MPI. There are a lot of different flavors of MPI. SGI calls ours MPT, Message Passing Toolkit, because there were other pieces along with MPI, such as what's called Arena software and a SHMEM library. Arena actually is being dropped, but it was around from IRIX days, even going back a long ways. It was supported for portability. So this module is primarily on the Intel compilers and getting a module command. We have to talk about the Sun Solaris originally, or Sun OS command called module, different than kernel modules. And then we have to talk about SGI's implementation of MPI called MPT, and it uses a daemon link chain, communication chain called array services to talk across the cluster. So I do at the end of this want to do a demo and get an MPI application running across all 4 nodes, all 4 Floyds. The next module then will be to get into CPU-SAT's NUMA placement, which are very critical on a UV system. And then lastly, look at PCP to take a look at the system. And then I'll try to do more of this tomorrow morning, first thing with PCP. So the first thing in this is the module command. Now, the module command is a way of modifying environment variables to load the needed environment variables for an application to run. So we have default modules put into user share modules module files, and then the location where to find the module files is the user share module init.modules path. Then we want to use the module command to show the currently loaded products, list the available products we can load, and then actually load some. So we're going to use the module command for MPT, Intel MPI. Also I'm going to use it for Perf Suite and PBS. The other part of this is the array services software, and array services is a token daemon chain, a communication daemon chain to spawn MPI work across the cluster. In older days, things would just RSH into the system and spawn the work, but having the array services daemon up and running reduces latency and allows you to get the work spawned quicker across the cluster. It also includes some cluster commands to run across the cluster, ainfo, arshell, ascheck, and the array command that we need to poke around at. Also, we're going to want to use the MPT user module that came with Foundation, came with the Performance Suite software, and then we're going to run this application. What I've got is 2 applications, a ping pong latency test and a graphic MPI application. Also, there is a new feature within Performance Suite and earlier Pro Packs called Perfect Boost. This allows other MPI applications to use MPT. So it will intercept HP calls, for example, for Fluent or something like that, and call MPT instead of the HP MPI. And also, I have not played with this yet, and this Checkpoint Restart is brand new as of this Performance Suite stuff. I did load it on one of the systems, but Checkpoint Restart is the ability to if I've got a job a process that runs for a month, maybe once a day I'm going to write a checkpoint image that I can recover from. I don't want to be 3 weeks into a calculation, have the system panic or power drop, whatever it is, and lose my work. So the checkpoint allows the application to save its environment off and then restart later. I don't know of anybody actually using that yet because it's a brand new feature, but it used to be around in older Cray and IRIX days. And the checkpoint restart implementation we are using is driven by Berkeley. Any questions? So I don't know how much background each of you have, but the module command has been around for a long, long time. I don't know, at least 20 years. For me, goes back to Cray's Sun OS and Solaris days. Then we did use it in Unicos and IRIX and in Linux. For a while there, it was included in ProPack. Then it was taken out of ProPack because it was standard. It is back in Performance Suite right now. And the ISSP package may be using it as well. We're just trying to make sure that we include it in ours because of dependencies to make it easier to load things like MPT. So we do include a module RPM. There are a couple of Linux and SLES RPMs that are included in our new Performance Suite and ISSP distributions to make it easier to load our products. So the module command is actually an alias built into the shell. We cannot be changing environment variables, fork off a child, change the environment variables, and then expect the parent children to know the environment variable changes. So basically, it's an alias in the shell, so when we change changes, all children know about the environment variable changes. So this is a dynamic way of modifying my environment. And personally, something like the registry in Windows is a big mess, hard to clean up, gets fragmented, has dangling objects, impacts performance, and tightly couples everything that everybody does into one registry file. The modules environment makes it a lot cleaner and decouples things. One of the things is, in the old days, if I moved an application, users would modify their .profile or .bashrc files to modify their path and stuff. Trouble is, it broke easy, and then I'd have 100 users in the data center that would have to change their .profile, .bashrc files. So this centralizes all the configuration information for a product into one place for the administrator. Within SGI, the stuff is within a /SW type of mount point typically. Anyway, Linux and other people are traditionally putting these products in /opt. The problem is that /opt can get stepped on by an OS installation, and there are things in /opt that are part of the main distribution of the root. So within SGI, we no longer use /opt because that gets stepped on. So we instead use /SW as our naming convention to put what used to be in /opt. So the things I put in /SW are third-party vendor applications that are not tightly coupled to a distribution. So with the module command, I can modify my environment variables. Each product will have its own module file. And then each module file, by the way, is written in TCL, TKTCL. And it contains the information needed to configure the environment for that application. So a user's environment can be dynamically modified using the module command. Now, there are a lot of sites that do not use the module command. Instead, they just hard code the run scripts that they're doing for their batch work. Module files can be shared by many users in the data center, and users can have their own module files. There are actually two module file packages. There is uppercase modules, and there's another one out there from Red Hat called lowercase modules-environment. They're the same product, just slightly different tweaks here and there. So an RPM-QA and grep for uppercase modules is the package that we are including in our performance suite. It's installed by default in the user share modules. Documentation is listed there. And one of the things here now, you've got to be careful. When you log in, you edit the ITSE profile.d modules script, which creates the module alias for you. However, there are times that you don't run that module profile.d module file. For example, the VNC remote desktop. In those cases, you may have to manually run the module script to get the module command loaded. Another example I often see is if I SU, I might not have the module command within that SU environment. So there are times that you don't have the module command and you need to actually source it. A third example, batch. So batch doesn't execute this modules.sh, and therefore you usually have to source the module command. And I'll show you that a little bit later. So there is a module file directory, user share modules, module files. Also, we often put it in a /SW so that if I rebuild my root and user share gets replaced, I don't lose my third-party product module files. And then in user share modules init, there is a modules path, and that says what directories do I look for module files. If I put them in SW module files, then I'm going to add that into my .modules path. Again, back them up that are in the user share modules one, and Performance Suite is putting module files in the user share modules module files directory, which can result in losing them if you've made changes to them. They don't get changed when you do a module package upgrade, just if you reinstall root. And again, we are using a /SW file system concept because SUSE is going to be putting stuff in /op when we install, and I don't want to have to clone or deal with the SUSE stuff that goes into /opt. Oftentimes /SW is a separate disk drive, a separate spindle, and when I reinstall the OS, I don't step on /SW. Does that make sense? Are we okay? So some of us have been around long enough to use the old /opt, but again, /SW is a preferred way now because there's too much stuff being put into /opt. It's no longer third-party, unbundled, decoupled products in /opt, but Firefox and all kinds of things are going in there, desktop managers, so forth. So here's an example of a module file. Now this is all written in TCL. So the set creates an environment variable called manprev. And what they're doing here is the brackets are saying substitute and then execute the man path, get rid of all your errors, and that substitution then results in manprev being your prior man path. Then we're going to create the environment variable man path. Now I didn't write this example, I probably could have done that all in one command. And then I'm going to prepend in front. There's also append at the end. But I'm going to prepend to the man path my opt SGI man directory. I'm going to modify my path and put opt SGI Perfect Boost bin at the top of my path. And then I'm going to add to the top of my path where to find the library. So that's a rather simplistic example. In lab, you're going to work and create one for the Intel compilers. Now, there are example module files in the lab tarball. So if you go to that UVSA1 lab files directory, there should be like a modules or module files directory that has an Intel one, a Perf Suite one, a PBS one, that sort of thing. So these are aliases built into the shell, and one of the things that's not shown here is I may have to, for example, in a batch job, source /user share modules init bash, for example. And I may have to do that to actually get the module command known within my environment. So I mentioned 3 times. Batch work doesn't pick up the profile directory, profile.d directory. The VNC viewer VNC port, remote desktop port, does not run that stuff. And also SUing around, I might not have the module command available to my shell. So the module command is user interface, dynamically switch compilers. I may have a Intel 10 compiler, Intel 11, Intel 11.1. Now 11.1 is what we're using for UV and Nehalem, and it understands the Nehalem architecture. So got an example here. They did a module list to list the modules. Somebody had already loaded the MPT module package. Did a module avail, note where it went to look for it. And in there we've got, for example, the Unified Parallel C, Perf Boost, MPT, Perf Catcher. Let's see, so that's five module files that Performance Suite loaded for us. So they did a module load Perf Catcher and then list, and now we see it loaded. They also should have echoed path, man path, and library load path too. Let me come back to that as a demo. Any questions? It is very important for you to be able to maintain and repair module files. Haven't heard anything, so moving on. Array Services is a MPI, MPT service set of daemons that talk across a cluster. SGI at the time decided to call a cluster an array. Just like disk arrays, they made the name convention of Array Services. This is really cluster services, primarily to support MPI applications across a cluster, multiple hosts. Now we have Floyd 1, 2, 3, and 4, so the array services can talk between them. So a group of hosts in clusters, they often call it a node, like on ICE we call them a node, but we group these things into a cluster. Potentially greater performance of the application, but the application has to be written using MPI. You have to rewrite your application. So MPI is a library call interface for parallel distributed applications. The other paradigm, again, was OpenMP. You do not have to rewrite your application for OpenMP. You simply find your hot do loops, your time-consuming do or for loops, and tell the compiler to make it OpenMP multi-threaded. Most sites, most vendors, I should say, application programmers will start off with OpenMP because it's a quick, easy way to get multiple CPUs involved in their program and problem. Basically spread a do loop, an iterative operation across multiple CPUs. However, OpenMP is limited to what's on the system, 4096 CPUs. So most vendors will start off with an OpenMP application because they can get multi-threading quick, validate their results, and get multi-processing capability. But then they're going to move to an MPI implementation. And for example, Fluent has multiple MPI applications. So Fluent you could run with HP MPI, you could run with Intel MPI, you could run with MPT. And when you start up Fluent, there are command line options to say what flavor of MPI is Fluent going to use. Now MPT has been around as long as any of these other flavors of MPI. It actually started off in Cray days. So it certainly goes back to the late 80s, somewhere around there. It's a library call interface, and it doesn't care how it's talking to the other processes. So it spawns processes across some sort of interconnect. A lot of sites will get a large SMP system and do shared memory. So rather than having 1,024 4-CPU systems and having 1,024 nodes and roots to manage, they might put them together into a 4096 CPU system and run that entirely with shared memory. Now that is going to be your best performance, lowest latency situation. The other options, though, MPT will automatically look for other interconnects and say, do you have NumaLink, do you have InfiniBand, or is it just TCP, a normal GigE network interface? In fact, we have customers out there that run all three of these within the same cluster. So MPT is smart enough to say my neighbor thread is on the same CPU, so I'm going to use shared memory. Or they might say, we're on the same system, so let's use NumaLink, which does include possibly the GRU. You could almost call the GRU another media format here, or media type of interconnect. But the GRU is really part of NumaLink. We also, if we're going to go larger than that, might have customers that are using InfiniBand, and maybe they've put, I know, for example, NASA Ames with the Columbia machine would put everything together as NumaLink as big they could, and then use InfiniBand beyond that. So their large Columbia system is a combination of all three. However, now with UV, the intent is to get rid of InfiniBand because we can now scale NumaLink to whatever they can afford in terms of number of sockets. Now, latency time frame, this is all rough and your mileage may vary, but these different types of interconnects are latency communication driven. So if my application spends a lot of time talking between threads, these different interconnects can have an impact. So where I put the numbers, TCP, to pass a packet back and forth, I'm going to say somewhere around 80 microseconds. Then, if I go to InfiniBand, I can get that latency for a packet down to about, I'm going to say 10 microseconds, and I'm just picking rough numbers. Then I can get down to NumaLink, and now in NumaLink, I'm going to put it at 1 microsecond, but we are getting faster with the newer systems. And then shared memory, I'm going to put at a 0.5 microsecond. And again, these are rough numbers just to give you an idea. We have a program we're going to run in class called MPI Pong, and these are the types of numbers I typically see. Now, if I were to scale it up and start going 16,000 ranks or something like that, these numbers are going to go up. But this is typically like between 4 threads and how long it takes to communicate between the threads. We okay with that? Any questions? Array services is meant to reduce this latency so I don't have to go through the process of talking to XINAD, that then's got to spawn off a remote shell daemon, that then got to spawn off the shell. So having the array services daemon up and running makes it quicker to spawn off work and reduce the latency to initiate ranks or MPI threads, MPI processes across the cluster. Any questions? So there are 2 array services packages. The standard array services is using RSH and our login, and therefore is not encrypting across the network, and things can be TCP dumped and snooped on. Now, in a lot of cases, once you get into the cluster subnets domain, you've already gone through security validation, but there are sites that want further security and shut things down with secure array services that's using SSL and SSH between things, and therefore everything on the network is encrypted. Only one of these can be installed. And across my cluster, they all got to be the same. So I'm going to have to watch for that today. And they are configured the same way, except with secure array services, you have certificates that have to be dealt with. I am not going to demonstrate the secure array services today. Also related to the MPT, we also need this proc set daemon up and running. So you got an array services and you got a proc set, and then there is the MPT package itself. Again, this array D is communicating between hosts within the cluster. You could call that a host. And the machines are defined in arrayd.conf and authentication in arrayd.auth. I need to go into those files for demo today. The lab is going to have you edit those by hand with VI. but it can automatically generate and push that file out to every node with array config. I'm going to demonstrate array config, not by hand. Then I've got to make sure that the array daemon is on and started and procset is on and started. So array D is using our login to talk to things, and then there's this array D services that communicates. One of the things array D does is assign a global array session handle in ASH so that all processes, threads, and ranks from a job or a MPI application all have the same handle. It will forward array commands like PS across the cluster. It maintains a database of the hosts that are in there. And I should mention here right now, there is an AS check command that will check the configuration, check the database, so to speak, and check to make sure that all the hosts defined in it are talking and have an array D up and running. Also in MPI, the array daemon is polling for death of child. And the machine ID, there's going to be a machine ID, is in the ASH, in the array session handle. Again, I mentioned the whole purpose of the array D is to, one of the main reasons is to reduce latency, so we don't have to go through all this stuff. Okay? So all of that overhead is removed. Also, the communication between these daemons is in var run array services. There's a network socket and there are error logs in there. So you do want to be aware of var run array services. And I do want to run my MPI application across all 4 nodes in our cluster here this morning for a demo. So here we're just talking about there should be an array D here, and then a remote array D here. And again, if I'm submitting work, this drawing's kind of wrong here. A-info, array, AR shell, and A-kill will all talk to the local. And then MPI run is going to talk to the local. And then the local will talk to the remotes. So there should be another array daemon visible here. And then if it's local, it's going to spawn off an array, an A.out master MPI run, which will then spawn off the individuals. This drawing's kind of a little old. There are array services commands available as well. Let me just go through them. These are the ones I'm going to do in demo here. So A-info has a bunch of options, but we can find out what sessions we have. So these are 3 different MPI configurations or array session handles that are running at the time. And then I can do a -H on a particular handle and find out what PIDs are in it, and then I could actually PS it. The array command, I can kill things across by ASH. I can do a PS. I can suspend, resume, or send signals, and get an uptime and a who across the array. So here is an example of a who and uptime. Now in this example, it was all the same host. It was not a multi-partitioned example. And I can also do this R shell, but remember we need to have RSH working in order for that to work. And RSH is not loaded by default. I think the lab will have you load, or actually earlier in the setup lab, we loaded the RSH-server, and then you got a .r host file that you need to get working. So key thing here is the arrayd.conf. But mostly I just want to go through the array definitions, and then there's some other things in there, as well as authentication. So looking at an arrayd.conf, the main thing I've got here is the name of my array. In this case is going to be called default, and the machines that are in it, in this case just one machine, is uv-sys. All array services are talking in port 5434, and this is an important one down here. The default array is going to be default. So let me save that for demo. So they just continued on with the arrayd.conf file. Here's the other commands that you can run. So here is what I'm going to do in lab. I'm going to run array config to configure it. I'm going to call the array Floyd. I'm going to make the array d.confs. I don't want any authentication going on, no RSA keys or anything like that. I'm going to go as simple as possible here. And these are the 4 hosts that are up and talking, okay, that I'm going to configure into my array. And I'm going to go through this live, but there's a whole bunch of output that I snipped. When I was done, I did an AS check, and I see that everything is okay. No errors were found. We okay? Any questions? So to run the application, I'm going to do a module load MPT. I need to get the runtime libraries. By the way, historically, MPT was in user bin, and you didn't have to load a module. So I'm getting a lot of people that get bit not realizing that we now have to do a module load MPT to get the MPT stuff. That was not true before. Then I'm going to run my applications. You don't want the number of threads to be more than the number of CPUs on your system. How I spawn my work is going to matter. If I've got 4 arrays, I might want to put 1 thread round robin across each of the nodes instead of node pack. I can interleave across the nodes in the cluster, or I can pack 1 node, then node pack the next, then node pack the next. And again, we're trying to reduce latency startup with the array daemon, and there is some graphical data. I've got to look at this. ClusterViz and PMG cluster. Are they even on the system right now? I've just got to check that. Yep. Yep, they're both there. So that is one way of looking at the cluster. When you're in ICE, there's a PM ICE utility to look at a cluster, but that is unique to ICE's hierarchy. So I may try to get ClusterViz or PMG cluster working today in demo. So I'm going to compile my application. I've got a link in the library. I've got to have loaded properly. Then I'm going to do an MPI run and spawn off 4 threads. And then tomorrow morning I'll actually bring up PCP and monitor the stuff. And there's another one, -stats. So here we're running across 2 threads. In demo, I want to get the GRU involved, and the stats file will tell me if the GRU is being used. The other thing I also have to have is this program in the same location on all the nodes. So I may have to push it, run it as guest, and push off a binary to all the nodes. But that's why I want to get to an NFS-mounted root for our users so that I can run it across the cluster. If you are using PBS or SGE or LSF, you kind of need a wrapper around MPI run. This is to make sure that a job cannot break out of its CPU sets or nodes that were assigned to it. So there is an MPI exec MPT. Same syntax, it's just a wrapper around it. And this is brand new now. It's been around for over a year, but it's now integrated into Performance Suite called MPI Inside. Now, there used to be a PCP probe, MPI Viz, that would do this, but that's no longer there. So MPI Inside, let's see, you basically are running your application as a child of it, and then it's going to kind of collect communication overhead statistics for your application. So down here, I'm getting elapsed times for each of the threads, how much time I'm sending data, receiving data, or trying to synchronize my barrier. Now, barrier synchronization is a big topic. I spend time on that in my UV system analysis class. And in fact, one thing I'm looking for is the hub has something called the MPI offload engine, the MOE. And there is hardware support for MPI, I should say MPT barrier synchronization in there. So that we've got special hardware counter or hardware communication channels in the hub to reduce latency on barriers. Prior to this, everything was going through memory, And in fact, OpenMP would still be going through memory because that's from Intel. And then here we're getting specifics about, for example, megabytes sent and received for each of the CPUs. And there's a whole bunch of statistics that come out of this. And a lot of that is another class, just letting you know that the utility is there. And the other utility is the SGI Perfect Boost. So this is fairly new as well. Performance boost for MPI applications that were not compiled with MPT. So it's a wrapper library. You need to have MPT 1.23 or later. There's a user module in it. I guess I shouldn't be ProPack anymore. And then this example runs an Intel MPI application as an SGI MPT application. So here I'm saying -I MPI for Intel. And the other thing, I have not played with this at all yet. It's been years since I've touched Checkpoint Restart, but it's now part of SGI's MPI package. Enables MPT jobs to be checkpointed and restarted later. You may not actually ever restart. The checkpoint might be for recovery if the system goes down. Another thing that sites were doing is job preemption. So I don't know when PBS Pro will use this, but right now, if I have a job running in PBS Pro and somebody else of higher priority submits work, my job would be preempted. And my preemption would be done by a suspend situation, which still means that I may be using up memory and have to have an impact on the system in a suspend mode. In the future, we'd like to see PBS Pro do that preemption through a checkpoint, and then when the other job is done, the job that got preempted can get restarted or resumed. So this is using the Berkeley implementation of Checkpoint Restart, and it will pause your MPI application and bring it into a safe state. We can't randomly checkpoint processes if they have open network sockets, but if we're all within the same NUMA-link system, then we are able to keep track of the open sockets across the cluster. And again, it is supporting the UV, and if we have a job that is sitting there in GRU and maybe InfiniBand, we can still checkpointing them. Limitations, not checkpointing on files. I'm going to have to check on that. I'm assuming that somebody will put the slide together, but if you checkpoint when you have open files, the state of that file is not something predictable when you do a restart. This is what I talked about, having a safe checkpoint situation. So I've always discouraged periodic checkpointing because the system does not know when it's safe to do a checkpoint when the application may have open network sockets or may be doing file I/O, things like that. So I've always encouraged the application to do its own checkpointing so that it can save off files, close off things, shut down anything that it needs to be safe, and then do the checkpoint. Limited support for some of these other environments. So it's just a first implementation. Okay, a real big slide here. 1029 is about the hub. So the hub is what's unique about the UV system. It is an SGI proprietary chip. So what we have up on the top here is our socket interface, and we're connecting into the Intel's QPI, Quick Path Interconnect. So this socket, this hub, is a bridge between my local and my remote homes. So off here is my local home, directory operations associated with memory requests. This is our cache line coherency that I talked about. Notice they're kind of drawing off of here my SRAM for the directory memory DIMMs that are out there. And then the remote home is processing coherent and non-coherent transactions across this common system interface. When I talk about cache coherency, here's my intervention and invalidations that are coming off of that. Also in the hub are two GRUs, two different block transfer engines. Then we see the 4 NUMA links, that are coming off the hub. So we're converting quick path interconnect into NumaLink protocol. And we got a router in here to do that. And lastly, the local block. So the local block is what we were just talking about. It's a software interface to configure various functionalities of the hub, doing things like interrupts, error handlings, synchronization. I was just mentioning MPT uses the hub for synchronization, not memory. And we can even pass some short messages through the hub. Some of us that were back on Cray YMPs and stuff like that, in the old days, some of the stuff was built into a Cray. And now this is the first implementation where MPT is using it in an SGI environment. Questions? Also part of the hub then was that BAU, Broadcaster Accelerator Unit. This is for TLB coherency, translation look-aside buffers. And then the MOE MPI offload engine is really part of what we were just talking about here with the synchronization events. Are we okay with this drawing? It's rather messy, but kind of give you a big picture of the things that the hub is providing. Any questions? There are statistics that come off of this. Very, very difficult when you've got a lot of hubs out there, but basically we're doing a NumaLink summary here. Now, the hub stats is going to do everything that's going on with the hub during the interval. So I just did a sleep 60 during it rather than run an application. And then I'm able to see the ports and then the receive and transmit off the different ports. The local home, the remote home, and the NumaLink traffic. And then we can see it on a per link basis. There's no PM chart, and PCP can get to this stuff, but there's no GUI to look at it yet other than the flat PM chart. I'll have to do that tomorrow. Also part of the user environment is the GRU. Now I do not expect most people to be programming for the GRU. Rather just letting the underlying UV software use the GRU. So by default, the GRU is used by MPT. There's also a library known as SHMEM. SHMEM goes back to Cray days as well. Original Crays did not have IPC inter-process communication. Their real memory machine concepts did not allow memory addressing into messages, semaphores, and SHMEM stuff. So they had to write their own library. And that library was ported into IRIX and then into Linux for portability, primarily used in the weather market, weather applications. There's also this new unified parallel C compiler. And then also the GRU is used by interpartition communication. This is what I'm going to do this morning, get XPC working, XPMEM, XPNet, and I need to add this in, I'm double check it, but XVMA is also part of this. If you kind of do a mod probe or mod dep, you'll see that XVMA, XPMEM and stuff, and XVMA are dependent on each other. Now there is a GRU developer's guide out there, and then some packages that are needed to do that. There is a kernel module, there's a library interface, development RPM, include header files, .h files. Also, Dimitri found this yesterday, the OLGRU is a diagnostic that's out there now. I would advise running it. It's only been around for about a month, I think. I didn't have it 2 months ago. But these GRUs are rather new, and if your system's idle, there's nothing wrong with getting that thing busy with this diagnostic. I've not run the diagnostic yet.
Dave, could you go back to that hub stats
Sure.
for a second?
Sure.
I'm trying to run that on Floyd, and it's not working.
Yeah, you're going to need to activate it first.
Oh, okay.
So these statistics are not on by default. Look at like a -A option or something like that. Let me come back to you then, if that's okay.
Yeah, that's fine.
But yeah, these statistics that are coming off of the hub, the GRU statistics and stuff like that often have to be turned on. And there is a link stat command. Did I get that in here? No. There's also a link stat command. Look at link stat. Link stats. There's a -A option there to activate these statistics. Okay?
Okay.
So let me come back to that with the PCP stuff too. Okay, anything else? So I did activate it here, but I did have to turn some of this stuff on. And I brought up PCP, let me say that for later, but here I'm looking at transmits, it looks like receives here, and transmits down here. And it's kind of interesting where when my application finished, I had a huge, this was the GRU, a whole burst of GRU activity at the end of my application. Now I'm going to demo the PCP stuff tomorrow, first thing. Let you review it and play with it overnight. I'm just going to get some MPI applications running and do some D-play CPU sets in lab today. Or I should say in demo. Now if I'm running with MPT, there is this -stats. And I'm going to do this in demo and specify the host, the number of CPUs, and there is a verbosity option to tell me how things are set up. And then there are a statistics report to tell me how much the GRU is being used. Now you've got to be careful here. Remember, if I'm only 4 threads wide and I'm on the same blade, there's no point in using the GRU. The GRU is meant for large multi-rack clusters, and I don't have a system big enough to show the benefits of GRU, in my opinion. So when I'm looking at the statistics and using GRU, it's higher overhead than using SHMEM because I've got such a small system. So when you're using MPI applications, you have collective calls, broadcast and reduce, and you have point-to-point calls, send and receive. 2 different types of MPI library interfaces. Point-to-point are synchronous, collective are kind of asynchronous. So we're able to see number of requests sent, also message headers, and then here, number of bytes transferred using the GRU. I want to get these numbers actually doing something. There should be another set of counters here visible, and that is the single copy. Again, this is not a tuning class, but there's also single copy capability to reduce bandwidth, or to increase bandwidth. Normally when 2 threads are talking to each other, there are 2 buffers between them, which means there's an extra data shuffle, a data copy between one buffer and another. So I want to demo that here coming up. Any questions? So that's kind of the end of this. I want to go to a demo, and then we'll take a break. Then we're going to have to come back and do the time-consuming one. Actually, all 3 are time-consuming today. But we need to come back and get D-place and CPU sets at PBS Pro working. And then lastly, PCP. Now, based upon time, I might not do the PCP lecture today. I might save it for tomorrow and try to give you more time on the lab and then do the lecture after the lab. That might work our clock better too. Let me see what we do there in the long run. So hopefully we're all still online and alert. I'm going to go to my system. Now, you should be able to see my desktop. Let me get out of here. So I'm going to log in as guest. I want to run this stuff as guest. Oops. And the first thing I'm going to do is a module command. So if I do a module list, I currently have no modules loaded. If I do a module avail, there are a whole bunch of modules available on my system. Notice I've got the same directory twice. It's recursive. I don't like that. It's noisy. Also, again, here are my modules. So there's that MPI Inside. I've already dropped some modules in here, Dimitri. So I was playing with Perf Suite and stuff like that overnight. I dropped in a PBS module already. And then here is an example of an Intel module. Now, in lab, you're also going to load the Intel compilers. I had no slides on that, so you're just going to have to follow the procedure. So first thing is, I don't like this. So I'm going to SU to root. First of all, let me see if module is there. Look at, no command, module not found. I SU'd. Let me try that again with the dash. Now it's there. Okay? So people will often do this, SU to root. Module command not found. So in that case, I know the path, but I've got to do a source or execute the user share modules in it, and then your shell choice. I'm a bash person, so I'm going to invoke bash. Now if I do modules, oh, wait a second now. Oh, module, I'm sorry. There it is. Yeah, I spelled it right before. Okay. Now the other thing I didn't like here, I'm going to go into user share modules init, and there is a .init path. Oops. .modules path. bi modules path. And this is personal preference. I don't like to see everything twice. So I'm going to comment out user share modules because right here we do user share modules, module files. So that's personal preference. And maybe if I created a /SW, I might put that in here as well. Okay, I'm going to do a make there on S-P /SW/module files. And let me just move PBS to /SW/module files. Let me move the Perf Suite stuff to, I'm just moving mine out of the way. And let me move PAPI. PAPI is your performance API for hardware counter access. Okay, so now I'm going to do a module list. Nothing's currently loaded. Module avail. And I am still getting the older path. That's because I have not re-invoked the module command. So I'm going to exit out of here and go back in. This time I'm going to use the dash. Now I'm going to do my module list. Nothing. Oh, we did get MPT loaded by default this time. Not sure where. ls/itc/profile.d. SGI Diagnostics. Well, I'm not sure where it's actually loading that one. Let me cat itc profile.d/modules.sh. Not loaded there. Again, this is what I did by hand earlier when I didn't have it in my path. So module avail. And note now I have the SW directory in there, and I got rid of all that noisy stuff. I got rid of all this stuff, and I still have this. Now again, the advantage is I don't have to edit my dot files, and then when the administrator moves something, it doesn't break things. And these module files can be OS and hardware specific. So I could load an Intel module file, and it would figure out for that OS, for that platform, what the proper path is to get the proper binary for that particular environment. So it's not uncommon to see these have multiple environments in them as well. Any questions right now? Okay. So, in my guest directory in UV, there is a MX, well, let me just first of all go into real WL. So I got a bunch of programs in here. Here's the OpenMP version to run. We'll poke at that later. What I have here, code 6 is an MPI application. I'm going to do more on code 6.c. So here it declares this is MPI. We have to define some things. Every MPI application starts with an init. This is what's going to spawn off all the threads. And then we figure out what is my rank, what is my thread number. Was I the 5th one spawned? What's my spawning order? Where was I spawned in the sequence? And how many ranks or threads were actually spawned across the cluster? Then I'm saying if my rank is 0, if I'm the master thread, then we're going to print out a header. And then basically it's going to sit here sending off these messages, round and robbing the messages, and then waiting for synchronization, keeping track of that wait time. And then here it's actually doing the send, receive, basically doing a ping pong test, and then computing latency and bandwidth and printing them out. And then every application ends with an MPI finalize. We don't need to spend any more time on this actual code, but that's the heart of it right there. And then this is the synchronization point. Okay? So I've got that application. So I'm just going to do it, first of all, module list shows nothing loaded right now. So I'm going to do a module load MPT. Okay. Module list, and it is loaded. I'm going to echo $path, and note what got put at the beginning of my path. Okay. I can also do a module unload MPT. I'm just going to do an MPI run, not found. Where is MPI run? Not found. Which MPI run? Not found. I'm going to do a module load MPT. Type in MPI run. It was found. And it's in opt SGI MPT version level. You have to be very careful when you have multiple. Let me just see here, RPM QA type grep MPI CH. Okay, QA. I'm just seeing if there's another MP flavor loaded. There is not right now. I don't want to break this system right now. MPI-selector. Pay attention here. If the customer is loading off the SDK, the OpenMPI or the MPitch or the MBAPitch, you get another command called MPI Selector. That will break the module command. That will break modules. So anyways, I've loaded my module list, it's loaded, and I have GNU compilers, so I'm going to do a GCC-L MPI to include the MPI. Let me do it without first. Let me just do a GCC on code 6.c, and it says, hey, you're missing these library calls, undefined reference. So now I'm going to do a -O code 6-L MPI. And now I should have a code 6 program. Okay? Now to run it, first of all, I'm going to do a PS-E and grep for array. And array daemon is up and running. I'm also going to check for procstat. And procset is also running. Okay? Now I'm going to only run on my own machine right now, so in MPI run -np, I'm just going to go 2 threads wide and then /code 6. And there we are. So this is the size of the packet that they're passing. This is a ping pong test. What's the size of the payload? Here's my latency in microseconds. And then here's my bandwidth. Notice as my packet size goes up, the latency, I was talking about 0.5 before, they were at a 0.38, and the latency is going up to 371 microseconds, but the bandwidth is also going up. So in lab, you're going to play with this and see what you can do to reduce the latency and increase the bandwidth. We okay right now? Any questions? So to look at that more specifically, I'm going to do a -stats, and it is possession sensitive. I can't put it after this. And I want to be watching statistics here with multiple runs. So I was at 371 and 5600, 370, 5600, about the same. And now I can see, for one thing, retries being set up here. We don't want that, so I can tune for that one. And here's the amount of memory sent. Notice it's all going shared memory. I mentioned single copy transfers. Let's see where those are. No single copy transfers, and GRU is not doing anything. Okay? Any questions? So I want to move that across all 4 nodes now. Everybody log into your system, lsmod, grep for XPC. Ouch, not there. So I'm going to do this for you, Dimitri, as part of the lab, but I want everybody else on there, Floyd 2, 3, and 4. So first of all, edit ITSI sysconfig /sys kernel. Oops. And modules loaded on boot down here. I want you to put in XPC. That takes care of the next boot. Also need a mod probe -a XPC lsmod grep XPC, and I now have XPC loaded. Remember how I mentioned I thought XVM was part of the GRU? Here's why. It has XPMEM and GRU as dependent packages. That's not part of the XVM daemon that we were talking about. This is XVM, these two. So I'm hoping everybody is going to now be able to have lsmod showing XPC loaded. And ITSI sysconfig kernel ensures it gets loaded on boot. Next thing I'm going to do now is go into ITSI array. There's my 2 array files. I'm going to do more on conf. And right now the default array is me, machine is localhost, and the default array is called me. So I want to change that, but I also need to change it on all the nodes. Also, there's the authentication. So right now it's saying no remote. I cannot do any remote MPI. but there's also the ability to say anywhere with no authentication, and there's also one with RSA keys that is doing simple. Okay, now let's see, can I ping Floyd 2? Well, .sgi.com, I can. I've got to figure out why DNS is not serving this right. If I cat ITSI resolve.com, I am searching the SGI domain, but apparently it's not coming up for me. So I've got to do this. Everybody should probably do this for the lab. I'm going to add the other three since House DNS does not have this right yet. And I'm doing a workaround right now. I've got to dig back into why I need a full path name. Okay, so let me just make sure that I can find my host now without fully qualified. Yep. There. And everyone's there. Okay, so I've got to be able to talk to these other nodes through the network, but they're using a network service port. 5354, I think it was. So now, here's the command. I'm going to do an array. Before I do it, AS check, and authentication is set to none. It's just giving me a warning, but everything looks okay. But I'm going to redo this now. So array config. By the way, this is going to have to be done one student at a time. Before you try playing with the array config command, check with the other three systems and the other three students. If we're all doing array config at the exact same moment, we're going to be stepping on each other, because this is going to SFTP files to the other nodes. -A, I'm going to name the array Floyd, just a generic one. M to make the files. What else did we have? Anybody got the slide? There's like a -D. Let me just check. So I need to upload the files, and to create, that's right. Oh, I wanted A to none, and then I wanted a big D to transfer files. So array config, -A to name the cluster, -M to make the files, -D to transfer the files to the other nodes, -A for authentication. I'm just going to go simple as possible right now, and then the list of nodes. And let's see how this works now. You okay with me? You following this? Speak up.
Yes.
When you got more than 4 nodes, this is very handy, and then you can put the nodes in a file instead of on the command line. So let's see if this works now. So we've already got one, but again, I'm going to overwrite it. Now, it isn't really telling me which node, but I'm going to start off with the first node here, but I'm going to say yes, and then the authentication, yes. Now we're on to another node. Notice it's doing Floyd 1 now, and it's going to SCP to it. Yes. Oops, YES. And I'm going to have to put in some passwords here. Oops, what's going on here? I must have been fat fingering it. I could have set up a RSA key or gotten SSH working quickly, but when you got a lot of nodes, this is probably the easier way. So Floyd 2 should be able, Floyd 2, Christina, take a look at your ITSE array directory contents now and try an AS check on your system. Floyd 3 should be okay now. And it looks like we're done. So everybody check their ITSE array directory now. I'm going to do an AS check just to see. And it tells me everything looks clean. Array W, no, array who. So I can see who. There's 1, there's 3, there's 4. Doesn't look like anybody's logged into 2, but that might be something with the who command. PS. So I can see the daemons that are running out there. Just not sure why I have 3 running, but I'm not going to worry about that. Floyd 1, Floyd 4, Floyd 2, Floyd 3. Okay? There's a info. And then it gives me the syntax, so I could do a info machines. And now I'm able to see the machines. They're all part of this. IDEN will still show up as unknown. I can do sessions. So there's my session IDs. We okay? There is AR shell, but that's really using RSH, or let's see what happens here. PWD. Need to have a host name. Let's see. Let's just do Floyd 2. And there it's running that one too. By the way, I don't think I have RPM-QA. Grep for RSH. There is an RSH server loaded. I was just wondering whether the RSH server was loaded everywhere. So check just to see. I'm just trying to confirm that RSH server does have to be there for this to work. Any other questions? So now I'm back to running that application, but I want to run it across the cluster. So now it's going to be MPI run. I still want dash stats, and then I'm going to do a dash NP, and this time I got 32 CPUs per, but I'm going to go 16 ranks per node. Now I'm going to do a Floyd 1, Floyd 2, Floyd 3, Floyd 4, and then run my program /code 6. Oops, you can't find the file. Okay, I'm going to make this simple and copy code 6 to my home. This is why I wanted NFS at some point. So now I'm going to go SFTP to Floyd 1, Floyd 2.
Hey, Dave, are there any Linux generic tools to copy stuff to a bunch of machines like, you know, Scotcho on...
Yeah, not that I know of right now. I've been thinking that myself, that the array services interfaces could use the SCASH or PDSH or like the Tempo CExec CPush. That would be a handy feature. Is that what you're thinking?
Yeah, that's what I was thinking.
Yeah. I haven't had the guts to RFE that yet. But yeah, the new array services commands that we were showing are rather old. They go back quite a ways into the 90s and stuff. And they're the CExec and stuff like that, the public domain shell and stuff like that are are much more common nowadays. Floyd 4. Oops. Okay, so let's see if that works this time. Maybe I was spelling it wrong before too. I might have been wrong before. There we are. So I need to have the executable exist on all locations in the cluster. That's why you have NFS. And that's why Dimitri was asking like a C push would be handy. Now let's see if this one works. It still doesn't like something. Do I have my syntax wrong? Okay. Getting closer. So, SSH to Floyd 2. Oops, SSH root at Floyd 2. XBC is not loaded. Let me just check everyone else. And Christina, put it in your csysconfig kernel as well. You can imagine having thousands of nodes and having to do this. So it looks like it is loaded everywhere now. Let's try this one last time, or try it again. And we're off and running. Notice the latency is a little bit higher. I've got more nodes involved this time, a lot more blades involved. And now in my statistics, notice I am now sending data through the GRU. Nothing's going single copy though. So you're going to get one of those reports for each of the threads. So I'm going to do a man on MPI.
You're running code 6?
Another one I wanted to check here.
Dave?
Yeah.
You're running code 6?
I'm sorry?
You're running code 6?
Yes.
Ah. Doesn't show up on Floyd.
It's done.
Oh, okay.
It's not running right now. Now let me leave that for the next module after we take a break. I want to actually, in the next two, then pin it down, put it in a CPU set, and then monitor it with PCP. Okay? So let me come back to that. But I wanted to check, it was MPI GRU, MPI buffs per proc. Okay. And then the other one was GRU buffer max. So I'm back, so it's export MPI GRU buffer max. I'm going to set that to 0. And then the other one was export MPI, what was it? MPI buffs per proc equals, I'm going to go 512, I'm just guessing right now. What I want to do is get single copy transfers I want to reduce the number of retries on a per proc by increasing that. And then I want better latency, and we don't have latency numbers right now. So let me try this again. Now, if you're going to watch, Dimitri, now's when it's going to be running, but it runs pretty quick right now.
Yeah, I see 3 of them.
And, oh, I did not hit any single copy transfers for GRUs, but I did get rid of my retries. Now, I'm not actually sure that this is working yet. Where was my other one, max, MPI GRU buffer max? Let me do a man on MPI again. Trying to increase the bandwidth, getting rid of a single copy transfer. Talks a little bit about it here. And MPT will be smart enough to say if this other rank is on the same socket or the same blade, to do everything through memory. Oh, the default was 32,768. Let's see. I don't know if that's bytes or whatever. Well, here it is. If it's greater than this value, we'll attempt to send it directly between the buffers and not through intermediate. And I had actually dropped it down smaller, and it should have. I'm not sure that this is working. I'm going to have to double check on this. This was added late. They weren't actually getting this statistic. I'm sure I've seen it work before, but I'm not seeing it now. Let me go, instead of 2 wide, let me go 32 wide now. So I got 4 32 CPU nodes within my cluster. So a lot more ping-ponging going on, but my latency still is around 1 microsecond. So it's running slower because there's a lot more ping-ponging going on, and it's a bigger group, but the average latency is still down in the 1 microsecond range. And we were at 0.3 when we were on the same blade at least. So are you able to see things running now, Dimitri?
Yep. You've got 34 code 6 is running on Floyd 1.
Sure. Now, if you've got X and stuff, let me do this here. I'm going to VI ITSI nodes, put in there Floyd 1, Floyd 2, Floyd 3, and Floyd 4. Now, let me get to my browser. This, by the way, is the point where I have crashed the web server before, crashed WebEx. So just to let you know, if we go down to take a break, I'm just waiting for numbers here. So, Floyd 1, colon 5801. I need a full path probably. Come on, connect for me. This hard part for me is actually getting a X11 type stuff going here.
Yeah, that was working yesterday, the remote
I know. Anyway, that example I still didn't, I got data sent via the GRU, but I was not getting the single copy stuff working. I'm going to have to talk to engineering on that. Anyway, if you did have X capability now, PMG cluster, that's what I wanted to show. It's not going to be able to open up a display for me right now. The other thing we have here, just so that you can, if you do have X11 capability, I have an MXP application in here. By the way, let me disconnect that. Let's see what Firefox does for me. That's the one that I'm usually using. I've been staying away from Firefox to see if I can crash with Explorer. I'm also going to go here. There it is coming up. So right now I'm going to leave Explorer alone, log in through the desktop. So PMG cluster, let me put it in the background actually. So there's my 4 nodes with all the CPUs. So let me go back here. And now you can see it go across the cluster and use all the CPUs that are out there. And the other one, cluster viz. So I created an NC nodes file and I'm looking at these, but these don't scale. PMI scales. If I've got 10,000 nodes, I expected cluster viz to come up by now. Of course, it's competing with my application too. There we are. I'm going to zoom in here a little bit. Rather noisy. I don't use cluster viz very often. PMIs is much nicer when you get down to it. So there now I can see all the CPUs go busy. We okay? Stop me if there's a question. Let's see. The other thing I was going to do now, let me do it from here. I'm going to run it as root. I don't like to run things as root, but if I can type. So I have a graphical interface for MPI as well. If you got kids in high school or anybody in college that's in computer science, this is a neat little thing for them to start with, to play with. And it's also an easy way to graphically demonstrate an MPI application that has graphics to it. Now, RPM QA -- last. On my system, on Floyd 1 for Dimitri, I did have to load the X11 develop package, and also had to load XAW3D development package. And then when I did that, you can make, there's a make file there. Let's see, do I have MXP made yet? Not seeing MXP there yet. So I'm going to do a make. And I now have a MXP binary that just got created. So now to run that thing, first of all, let me push it out. Let me copy it to root just to make, since I'm running as root right now. Oops. this way you know that graphics and Fluent and stuff like that would be able to work as well. So now I'm just going to do an MPI run -np2./mxp. Oh, cannot run execute. Oh, where are we? I had it working last night. It's empty. 0 size. Okay. MXP is the correct size there. So let me try it again. Sized properly now. My typo must have put an empty one there. SFTP to Floyd 2. About ready for a break. Okay, so now let's try that simplistically first. And there we are. And you can basically zoom in and, you know, Mandelbrot, fractal generator, whatever you want to call it. Is everybody seeing this?
Yep.
So now I want to add in, I can add a dash stats, Floyd 1, Floyd 2, Floyd 3, Floyd 4, and let's go 16 wide here. Now I don't have the monitoring tool running, but let me bring up the monitoring tool. Now this program is sitting in a spin right now, so all the CPUs are busy even though it's doing nothing. This is a spin type of thing. So you're really not able to see the load unless I were to quit or something like that.
It's pretty damn fast, though.
And there are times where you can actually see, I was trying to get it so you could actually see the interleave between things, where you can see one node work on one piece and another node work on another piece. So anyways, that's a slick little graphic tool to demonstrate things. Any questions? I want to take a break here. Let's come back in 15 minutes, quarter after the hour. Okay?
Yep.
See you in 15.